Hi, this is Dave Kirshner, and today we're going to be talking about IVC measurements. Now, the reason this comes up is because we can ask ourselves, well, why do we measure the IVC where we do? I was teaching a course a couple weeks ago with some colleagues, and this came up as a question in one of the sessions, and it was shown nicely by one of the patients that we were scanning. And so to begin with, I'd like to just go through the patient's views that we had looked at. This is a view of the IVC from the right upper quadrant. Now it's a little bit modified from the fast view, but we can still make out a number of structures. First of all, we have the liver and the diaphragm, and then just a little deep to the liver, we can actually see the IVC. In this case, we'll be seeing both of the lateral walls. Now when we look at it and compare it to the hash marks on the right side of our screen, it looks to be about 2 centimeters in diameter, and it really looks like it's collapsing less than 50%. But this isn't the standard view that we tend to go to when we're looking at the IVC. So let's look at the IVC from an anterior approach. This is the IVC from an anterior approach according to cardiology convention. And all that means is that the probe marker is in the right upper part of the screen and the patient's head is to screen right. We can still make out some of the main anatomy that we look for, including the diaphragm, the liver. Next to the liver on screen left, we have gas that's obscuring part of the liver as well as part of the IVC. Now that being said, we can still see just the proximal part of the IVC as it spills into the right atrium. When we look at this part, it still looks to be about 2 centimeters in diameter according to the hash marks, and it still really appears to be collapsing less than 50% as it spills into that right atrium. Well, so far, our views tend to be agreeing with each other. However, it's not just a matter of looking at the IVC right as it spills into the right atrium. We should be looking at it about 2 to 3 centimeters distal to that or further away from where it falls into the right atrium. We played with the patient's positioning just a little bit, and this is the view that we were able to get. This is the same view of their IVC in a longitudinal axis in cardiology convention. Let's try to pick out some of the anatomy that we saw in that previous view. Well, we can still make out roughly the diaphragm as well as the liver, and just inferior to the liver or to screen left, we have the gas that's obscuring it. Even though the gas is obscuring the IVC, we're able to see a little bit more of it, a little more distally, and those are its walls when the patient isn't in inspiration. What we can notice here, though, is on inspiration, we do have collapse. So although the diameter might be about 2 centimeters, the collapse does seem to be greater than 50%. If we were to put this into a clinical scenario, in terms of a patient's volume status or their ability to change their stroke volume based on a fluid bolus, this might change our management. This slide here is showing all three views from the same patient, the left upper being the lateral approach, the right upper being the sagittal view from an anterior approach, but only seeing that part that's just spilling into the right atrium, and finally the bottom left showing what the IVC looks like when we've moved back from the right atrium a couple centimeters. Well, why is it that the IVC acts like this? The reason's this. We tend to think of vessels as tubular structures, and then we'd think that, well, when they get smaller, they should just look like smaller circular tubular structures. And that works for the most part when we're talking about arteries, but in this case, we're not talking about arteries, we're talking about veins, and in this case, the biggest vein. So when the IVC is no longer full, it doesn't go to that same shape, it goes to more of a flattened shape, but keeping the same diameter. If we were to look at the same patient's IVC one more time, but this time from a transverse approach, so this is what it looks like in a transverse view from the anterior approach. We can see where the patient's right side is and where their left side is, and we can see as they breathe in and breathe out, we can see that IVC change ever so slightly. If we think that our first view was from the right side, cutting through in a coronal section, this is the view that we were getting, and it becomes apparent why it looked so big and why it stayed so big. But again, when we look from an anterior approach, we can see that that same IVC is much smaller and it's collapsing. So that's it, just a couple brief minutes on why we measure the IVC where we do. If you have any questions or thoughts, feel free to email me at my email address. This is Dave Kirshner. Thanks for listening and happy scanning.